This is Group 5, and our system was a hydraulic or pneumatic system, and more specifically we did a hydraulic lift. This was the hydraulic lift used. It's a standard motorcycle lift. You can see it just uses a hydraulic bottle jack to lift it, and this was what was used to measure it, more specifically this one, which after some work we were able to connect it to a computer and it would give us a reading in kilograms. Our final setup ended up looking something like this, with the Wii here on some boards just to get all the feet even, and lifted this motorcycle up. The system has two inputs, two levers that you can really interact with. The first one, this one, is the bigger lever, which forces the piston down and forces hydraulic fluid into the chamber, basically lifts the jack up. The second is this little lever, which acts as a relief valve, which moves the higher pressure hydraulic fluid into the reservoir and lowers the system. The system has two outputs. One is the lift height, how low or how high is it, and the other is the lift force, how much force is it actually lifting. The initial conditions are basically just how high the lift is and how much weight is on the lift, which are both related to the pressure inside of the hydraulic system. This is basically a video of how it was conducted. These videos go side by side. So this one starts right about now. And here you can see the reading in kilograms. Right now it's at about 239, which is really close to the published weight of the bike. There's the relief valve, which will lower the system. Here I had to adjust it to make sure it wouldn't fall off a little, and you can see that dip in the graph later on. This is lifting the system up using the larger lever. And this is pretty much where it leaves off, the measurement reading at 240 once again. This was the graph of the data that we got out of it. Here you can see it's lifted up, the pressure lowers, the bike drops. Here's me adjusting it, which, whoops. This is the low pressure reading when it's at its bottom state, and then when it's being jacked back up to its original state, this is the line that it sort of follows. And this is a second line here just with the published weight to see that it's kind of close to what it should be. So this is the ideal model sort of, but this was closer to an actual bottle jack like the one that was used. Normally it's a simple first order system, but when you consider the mass has to accelerate, it becomes a undamped second order system with the equations here. So there was some room for improvement. The motorcycle wasn't super stable on the setup, but it was, the only materials that I had. The motorcycle suspension left a little uncertainty in the results. Additional measurements, we could have gotten height measurements of how far it went up and how much force was actually being applied with my foot. Better sensors overall. And internal measurements of the bottle jack, being able to know the area and the forces and pressures of the inside would be helpful for this. But overall it analyzed a real-world situation, and it was a pretty good quarantine project.